Hi friends, in this video, we will learn about the different types of errors that can occur in a program and how you can debug them. To begin with, you might be wondering what exactly is an error. A program contains bugs or errors when it is unable to execute or produces an output which is different from what is expected. These bugs are generally introduced by a programmer unknowingly. Whenever you come across the term error, there is another term which closely follows it. It is debugging. Debugging is the process of identifying and eliminating the bugs or errors in a program. There are three major types of errors: syntax error, runtime error, and logical error. Let us go through each of these errors in detail, beginning with the syntax error. Syntax error occurs when the program contains any statement that does not follow the prescribed Python rules or syntax, which makes it difficult for the Python interpreter to understand and execute it. Some common syntax errors are missing misspelled keyword, missing colon or brackets, empty block, incorrect position of keyword, incorrect block indentation. When a code containing syntactically incorrect statement is executed using script mode via idle, an error dialog box is displayed which says invalid syntax. On closing the dialog box, the incorrect part of the code, which is the potential cause of error, is highlighted in red. This error can now be rectified by the programmer to execute the program correctly. When a syntactically incorrect statement is executed in the Python console, the Python interpreter displays it and also adds a little arrow pointing at the entry point or token where the error was detected. For example, when while true, print high is executed, a syntax error is raised with the arrow pointing at the print function, which the parser is unable to understand as there is a missing colon after true. Let us move on to the next type of error, that is runtime error. A runtime error occurs when the program is terminated prematurely by the Python interpreter, as it is unable to execute a statement although it is correct syntactically. The different types of runtime errors are import error, IO error, zero division error, name error, value error, index error, key error, type error, indentation error. Let us check out some examples of some of these errors. The zero division error is raised when a number is divided or mod by 0. For example, if n is assigned the value 100 and d is assigned the value 0, print n by d raises the zero division error as 100 is divided by 0. Name error is raised when an identifier is encountered which has not been defined. For example, if n is assigned the value 100 and we execute print d, it raises name error as the variable name d is not defined. A key error is raised when a key is not found in a dictionary. For example, let us create a new dictionary D with keys 1 and 2 along with the corresponding values string first and string second. If we execute print D3, a key error is raised as there is no key integer 3 in the dictionary D. A type error is raised while performing an operation on incompatible types. For example, let us assign 1 to n and string a to s. If we execute the assignment statement tot is equal to n plus s, it raises a type error as we are trying to perform an illegal addition operation on a string and an integer. The final type of error is logical error. It is also known as semantic error and is caused when the issue lies in the underlying meaning of the code, which leads to an incorrect output. As compared to a syntax or runtime error, there is no termination of the program. Debugging a logical error requires inspection of the entire code, as no guiding error message is displayed. Let us look into a program that calculates the average of two numbers, n equal to 10, m equal to 20, average equal to n plus m by 2. Next, we print the average. Upon execution, the result is average 20.0, which is incorrect as there is a logical error in the code. Since division operator has higher precedence over addition operator, m divided by 2 is computed first. The code can be modified easily and we can get rid of the logical error by enclosing n plus m within parenthesis. Now, the output of the code is average 15.0, which is the correct output.